Hello everybody, and once again we are back together, and we are going to be going through just some prelim preparations as you guys are preparing for the prelims. So I'm going to be taking you through some question papers. So if you haven't subscribed, please just make sure you're part of the family. All right, and today I'll be starting with the Eastern Cape June exam 2024 Maths Paper 1. Let's go through the first question. And please note that we do have our prelim preparation sessions that are happening every Saturday, right? And to get more details, you can look at the description of this video to get some contact details. Let's get right into our conversation. Right. All right, so firstly, we'll look at question 1, right? Let's try and go through the questions together. So we've got 1.1.1. So they've got x squared minus 8x now. So what I'm going to do is just simply expand into the bracket. So that will be minus 8x. And remember, a negative times a negative is a positive. So that becomes plus 16, right? Now, if I take the 25 to the other side, that becomes minus 25. This would be equal to 0. And I'm left with x squared minus 8x, right? This will be minus 9, right? 16 minus 25, that will give us negative 9. Right, and so we can actually just factorize there, right? This will be x times x gives us x squared. Factors of 9 such that when we subtract them give us 8. That will be 9 and 1, right? So that will be 9 and 1. And so this one will be negative and that positive. And so we've got x is equal to 9 or x is equal to negative 1. All right, now that is our first question. Right, now let's go to the second question. They say to us minus 3x squared plus 2x plus 2 equal to 0. So this is in terms of the standard quadratic form already. So they said give the answer to correct to 2 decimal places. So already this tells us that we are going to use the quadratic formula. But what I'm going to do is first multiply throughout by the negative, right? So that my coefficient of x squared is positive. So I've got 3x squared minus 2x minus 2. So everything else changes sign. And please note, what I do on the left, I'll do on the right. And in this case, anything multiplied by 0 still becomes 0. Now let's use our standard quadratic formula. So that's minus b plus minus the square root of b squared minus 4ac. And this is divided by 2a. Of course, we can substitute. I apologize. I'm just going to try and continue on to the other side. So this is minus a negative 2 plus minus the square root of b squared is negative 2 squared minus 4 times our a value is positive 3 and our c value is negative 2. Right, and this is divided by 2 times 3. Right, so that gives us 4 plus minus the square root of. Right, if you note there, if I add, that's going to be 2 squared, which is 4. And this is negative times a positive times a negative gives us a positive. So that will be 4 plus 4 times 3 is 12 and times 2. Gives us 24. So that's 4 plus 24. That will give us 28. And we divide that by 6. Now to get our values for x, in this case, remember they said correct to 2 decimal places. So I'll have 4 plus. In fact, let me just put that. So that will be 4 plus the square root of 28. And this will be divided by 6. Okay, I get my first answer to be 1.55, or in this case, x will be, so if we put a negative there, that will be 4 minus square root of 28 over 6, and that will give us negative 0.22. All right. There we've got our final answers, ladies and gents. And please do note, in this case, you could have actually just kept that negative there, but it's much easier to actually multiply throughout by the negative. Right, now let's go on to the next question, and I'm going to remove what I have here. If you want to watch it again, you can actually just rewind the video. All right, now let's go to the next point. Right, so we've got our inequality there. We've got x plus 3 and 5 minus x, right? This is less than or equal to 0. Now, ladies and gents, I want you to note your coefficient of x in the next bracket is actually negative, right? Now, which means that this is going to be a sad parabola. But what we can do to try and fix that is that we can multiply both sides by negative. Now remember, if I multiply by -1 on either side, the inequality changes sign. So what does that do? We have x plus 3, right? That remains as is. I'm going to multiply this -1 into that bracket. And so what does it become? -1 times negative x gives us a positive x, and -1 times positive 5 gives us a -5. But remember, I said to you, we need to, the inequality changes sign, and 0 times -1 still gives me 0. Now, what are my critical values? My critical values are -3, right? Remember, they change sign in that case. That would be -3 and 5. Now, where is this graph? Okay, so we know we've got plus here, negative, and positive. So, where would this graph be greater than 0, right? And by the way, we said greater than or equal to. So, at 3, our graph would be 0, but it's positive all the way till -infinity, right? But also at 5, which is included as well, because it is 0 there, all the way to positive infinity. That's where our graph becomes positive, right? And if, of course, if you don't understand this more, go and look at our video on inequalities, right? So in this case, what would be our solution? That means that x would be an element of -infinity. Remember, it must be in ascending order till -3, but -3 is included, right? But also, we know that it must be from 5 all the way to infinity. So that's what our answer looks like, right? Now, you can also write this as x is less than or equal to -3, or x is greater than or equal to 5. Right, and that is how the cookie crumbles, ladies and gents. Right, that's how I would have answered that inequality there. Right, let's go to the next one. So, they say to us, we've got the value there. Okay, so they give us that in brackets. Okay, in fact, 1.1.4, given x plus 3 over the square root of x plus 5 is equal to 1. They say x is an element of real numbers. They say for which values or values of x will x plus 3 be undefined. Now remember, that means that firstly, the denominator cannot be equal to 0, right? But also x plus 5 must be positive. We cannot take the square root of a negative number. So that means that in this case, x plus 5 must be greater than 0. Please note, we can't say greater or equal to. So in that case, x must be greater than 5. All right. Okay, awesome. Okay, so they say solve for x. So we're going to take that expression, Okay, and we're going to say, right, we've got x plus 3. Now note, in this case, this is 1 over 1, so we can cross multiply, right? So x plus 3 would be the square root of x plus 5, right? So that would be the square root, so this would be equal to, in fact, let me just swap them around. The square root of x plus 5 would be equal to x plus 3, right? But what do? We've got a square root there, so we're going to square both sides, right? So that means that the square of square root of x plus 5 gives us x plus 5, right? Remember that the square root and the square cancel out, and in this case this would be equal to x plus 3 squared. This will be x squared plus 6x, and please, you must be able to always work with square brackets very quickly, right? So plus 9, and in this case now we can place this standard quadratic form. X to the other side becomes minus x, so that's 6x minus x, which gives us 5x, and 9 minus 5, that would give us 6. All right, and this is equal to 0. Now let's try and get our answer there. Factors of 6 such that when I add them give me 5. That's definitely going to be 3 and 2. And this is equal to 0. And so x is equal to negative 3, or x will be equal to negative 2. Right, now which of these answers would actually be applicable, right? Now I want you to think about it. So we said in this case the restriction that we are given is that x must be greater than 5, right? You'll see, even if you substitute these answers back into the original equation, you'll see that it doesn't quite give you, you get a negative answer on your right hand side, right? So which means none of these answers, so this is not applicable, but also this is not applicable. Or you can write x cannot be equal to negative 3 and x cannot be equal to negative 2. Remember that we said our restriction says that x must be actually greater than 5. So that is how the cookie crumbles. Let's go on to the next one. So we are looking at solving simultaneous equation. Right, so we've got y plus 2x equal to 5. So let's call that our equation 1. And we've got 2x squared minus xy minus 4y squared equal to 8. Let's call that our equation 2. Now, in this case, from equation 1, right, we're going to make y the subject of the formula. That will be equal to 5 minus 2x. Right, you can call this equation 3 if you want to. And we are simply going to substitute in equation 3 into, now please note you can't substitute it back into equation 1, but we can substitute it into equation 2. So everywhere I see y in that equation, I am going to put 5 minus 2x. Now let's try and do that. So that's 2x squared minus x times y, which is 5, minus 2x, minus 4 times our y value is 5 minus 2x, right? Remember this is squared and this is equal to 8. Let's try and work out the value of x. So you've got 2x squared minus 5x plus 2x squared, right? Remember that's negative x times 5, that's minus 5x. That's negative x times negative 2x, that gives us positive 2x squared, right? So this is going to be minus 4, And I did say, guys, it is important for you to be able to work with square brackets very quickly. So this will be 25, so that's 5 squared, right? And you say 5 times negative 2x, that gives us negative 10x multiplied by 2 to get the middle term, right? So in this case, that gives us negative 10x, negative 20x rather. 10 times 2 gives us 20. And so we say plus 4x squared. Right, and this is equal to 8. So let's add everything up and let's see what we get. So 2x squared times plus 2x squared, that gives us 4x squared, right, minus 5x. Okay, I'm going to multiply the 4 into the rest of the equation. That gives us minus 4 times 25 gives us 100. So that's minus 100 plus 80x. Negative 4 times negative 20 gives us 80. All right, that's minus 16x squared. And this is equal to 8. Now, ladies and gents, all we need to do now is just try and identify our like terms. So negative 16 plus 4 gives us negative 12x squared minus 5x plus 80. That gives us minus, or rather plus 75x. And 100, if I bring this to this side, we have got 100 minus 8. That will give us negative 108. Right, and this is equal to 0. Right, now the question is, can I divide by a number, say perhaps 4, or can I divide by 2? What would be in this case the lowest common multiple? Right, let's quickly look at it. Okay, definitely 75 cannot divide into 12. However, what we can do is we can divide by actually by 3 for each term, right? Okay, so let's do that. Let's check with our calculator. Let's see, 75 divided by 3, that gives us 25. And 108 divided by 3 gives us 36. Okay, so let's divide everything by negative 3, right? So that will give us 4x squared minus 25x, right? That would be plus 36, and that we see everything changes sign. All right, so if you look at this once again, ladies and gents, what are the factors of 4 and 36, right, such that we can actually just factorize these. Okay, so I'm going to test it out. Let's see if we've got 2 and 2, and let's say 36 gives us, this is from, okay, so that would be from 40, in fact, no, that will be from 18, right? So that's 18 and 2. Would that give us 25? Okay, so if we say 18 times 2, that will be 36, right? But when we add those, they don't give us the numbers we are looking for. All right, now let's say 9 and 4 instead. Okay, so if I say 9 times 2, that gives me 18. And if I say 2 times 4, that gives me 8, right? So if I add those two, nope, I still don't get 25. All right, so we move on to the next one. Let's take 4 and 1. Okay, let's see if we take 4 and 1 and we take 18 times 2. Right, if I look at that again, so that's 18 times 1, that gives me 18. 4 times 2 gives me 8. Again, that doesn't give me 25. Okay, so remember, ladies and gents, you can just use the quadratic formula if you want to. Okay, nothing wrong with that. Okay, so if we try to swap the numbers around, let's take that 9 and 4 again. So if we take 9 and 4, right, so in this case 4 times 4 is 16, right, and 9 times 1 gives me 9. Definitely 16 plus 9 gives me 25. So that means this would be your first bracket, that would be your second bracket, right? And both your brackets would be negative. So we've got 4x minus 9 and we've got x minus 4. This is equal to 0, and so x will be 9 over 4, or x will be 4. Now that you've gotten the value of x, we can determine the value of y, right? We're going to substitute into equation 3, right? So substitute our x values in equation 3. So that gives us y is equal to 5 minus 2 times, we said it was 9 over 4, okay, or y is equal to 5 minus 2 times, remember we said our other value is 4. Right, and ladies and gents, I think you know how the drill goes here. So that would be 9 over 2. So that's 5 minus 9 over 2. And this will give us 1 over 2. Right, and in this case, our other y value, that's 5 minus 2 times 4. That will give us just simply 1. Right, I hope that you got it, ladies and gents. Right, and of course, as I did say, you didn't have to actually try to factorize there, right? All you could do is work out from the quadratic formula. Right, now let's go on to the very last question here. Right, I'm just going to make some space. Okay, right. Okay, so they say to us on the last question that given m is 108 divided by x squared minus 4x plus 8, right? They want to know where x is an element of real numbers. They say determine the maximum value of m. Now remember, in order for us to have a maximum value of m, we've got a fraction there, 108, which is a constant, divided by, in this case, a function, which is x squared minus 4x plus 8. Now, in order for this value here to be maximum, which means the denominator, there's nothing we can do with the numerator, right? So the denominator must be minimized, right? Now, there are two ways in which we can minimize the denominator, right? What's the minimum value of that parabola? So what we can do is you can choose to use calculus, or you can find, remember, if it was a parabola, it would be a smiling parabola. So where would be the minimum value? Your minimum value would be at the turning point. So we need to find out what is the turning point of that graph. Okay, so x value of the turning point, I can say minus b over 2a, right? So that's minus, our b value is negative 4, divided by 2a, that's 2 times 1. And so we get 4 over 2, which is equal to 2. Okay, right. So our turning point would be at x is equal to 2. But what would be the y value of the turning point? So all we do is we're going to substitute the x value into the equation. So that would be 2 squared. So where I see x, I put a 2 there. Minus 4 times 2 and plus 8. So we've got 4 minus 8 plus 8, which will actually give us 4. Which means the minimum value of this graph will be where x is equal to 2 and y is equal to 4. The minimum value is actually 4. All right, so what would be the minimum value of m? M would be 108 divided by 4. And so if we can take that there, 108 divided by 4, right, we get 27. So our value there is 27. Right, but what would have been another way in which we can work this out? We can use calculus, right? So remember, we're going to try and minimize. So remember, at the minimum value, the derivative must be equal to 0. Our derivative would be 2x, right? So the derivative of x squared minus 4x plus 8. So that would be 2x minus 4. Okay, and this would be equal to 0. So 2x is equal to 4. Divide both sides by 2, and x would be equal to 2. Now I want you to note, once again, to get the y value, the corresponding y value, all we'll need to do is substitute that x value into the original equation, just like we did right here. And you'd get y is equals to 4, and we do exactly the same process like we did when we solved initially. Right, and ladies and gents, that would have earned you 25 marks. I hope that you understood that, as we are going to go into the next question. And now let's look at question 2. They say, given the following arithmetic sequence, that is 2, that's -3, and -8, right? Determine the value of T43. Now, please, I want you to note, right, as soon as they tell us that this is an arithmetic sequence, we know that the general formula for any arithmetic sequence is a plus n minus 1 multiplied by d, right? So we know that our a value will be 2, right? And to get our common difference, we will just simply say t2 minus t1. So -3 minus a +2, that will give us a -5, right? And you'll see that this is the same if I say t3 minus t2, that will also give us -5. So our common difference is -5. So the first question says, determine the value of T43. So that means if I'm looking for T43, that will be A plus 43 minus 1 times D, right? So in this case, that would mean our A value being 2, right? 43 minus 1 gives us 42. So this will be 42 times the D value, which is -5. And quickly, we need to be able to calculate that. So that will be 2 plus 42 times -5. And that gives us -208. Right, so that is the 43rd term, right? Okay, so let's go on to the next question. They say to us, calculate the sum of the first 43 terms in the row, that is S43. Now that we've got term number 43, right? So please remember, for arithmetic sequences, Sn is equal to n over 2 into a plus l, right? Of course, you can always use the other formula, which is Sn is n over 2 into 2a plus n minus 1 times d. But of course, this would be slightly longer to do, so I'm going to follow the first one, right? So we're looking for S43. That will be 43 over 2. My a value is 2. And my last term in this case is -208. So minus 208. Right, so that's plus a -208. So let's find that value quickly. So that will be 43 over 2. Right, and we multiply that into 2 minus 208. And that is what we get. That's -4429. All right, please, you can verify that just to make sure that you get to the same answer. Right, now we go to the next question, right? They say calculate the value of n for which Tn is equal to negative 2023. Right, so remember, this is our term number, right? So in this case, remember that we've got our term number there, right? We said our A value is 2, okay? And we want to know what would be the value of n, let's say n minus 1, multiplied by our D value, which is negative 5. So if you don't mind, I'm just going to, it's easier if I write it this way. That's 2 times negative 5 into n minus 1 will give us negative 2023. Right, so let's try and solve that. So we've got negative 5 into n minus 1. Right, if I take the 2 to the other side, that becomes negative 2. Right, so this will give me negative 2025. Okay, so I can divide by negative 5. Apologies there. So divide by negative 5 on each side. So I'm left with n minus 1, which will be equal to. So let's get that answer quickly. So 2025 divided by 5. So that gives me 405. But please note, ladies and gents, that we've got a negative divide by negative, which gives us a positive. So that will be positive 405. And so n is equal to, now if I take the 1 to the other side, that will simply be plus 1. So that means that will be 406. Right, which means that the 406th term will actually be negative 2023. Right, I hope that that makes sense. Right, I'm just going to erase all of this quickly, right, as we go to the next portion. Right, so they say to us, given the example, or rather given 2 times 3x minus 1 plus 2 times 3x minus 1 squared, and so on. Right, so the first thing that they ask us there is for which values of x is the series above a convergent geometric series. So first of all, they tell us it is a geometric series, right? So what is our common ratio? Remember that for a geometric series, we've got a common ratio, right? Now, if you look at this, to go to the next term, what did we do? We just multiplied by another 3x minus 1, right? So which means the next term will be 3x minus 1 cubed, right? So we keep multiplying by that term there, which is 3x minus 1. Right, so that's our common ratio. You can take T2 divided by T1 to verify that. But now for a convergent series or sequence, right, we know that our R value, the common ratio, must be less than 1 and it must be greater than negative 1. What does that mean? It means that it must actually be a fraction, right? So that means that our common ratio, which is 3x minus 1, must be less than 1 and it must be greater than negative 1, right? So, and to work that out, so if I say 3x, if I take the 1 to the other side, but remember I also do the same on the other side as well. So 3x, right? So that's 1 plus 1, that will give me 2. And on the other side, I've got negative 1 plus 1, which will give me 0. And of course, I can divide both sides, or rather all the sides by 3, right? So that means that cancels with that. And so x must be less than 2 over 3, and it must be greater than 0. All right, so that is how I will get this series to be convergent, right? Now, the next part says to us, find the sum, right, of 2 times 2 times 3x minus 1 to the exponent k, where k is equal to 1 to infinity. So essentially, we are looking for the sum to infinity. Now, I want you to think about it. It's essentially kind of the same thing as what we had there, right? So it's the same sequence, right? It's the same series. But now, what we are doing is that we are substituting x is equal to 1 over 2. So let's see what that will give us, right? So that means that we're going to have 2 times 3x, or rather 3 times 1 over 2 minus 1, right? And what does that give us? So that's 3 over 2 minus 1, which will give us 1 over 2, right? If we multiply that by 2, that gives us 1. Right, now ladies and gents, I want you to please note what we are doing here is that we are simply going to multiply that into our bracket, right? We are raising this to the exponent k. Right, now if you had to look at it, right, you had to find your a value first. Okay, so I'm going to find my first term, right? We said our first term we multiply by 1 over 2 there, right? X is 1 over 2, so our first term will be 2 times, right? That's 3 times 1 over 2, right? Minus 1. Our k value will be 1, so that's to the exponent 1, right? And so remember we said that's 3 over 2 minus 1, which will give us 1 over 2 times 2, so our a value is 1, right? And what is our r value? We can see that you will keep the next one will be k, that will be exponent 2. So that means that our r value will simply be 3x minus 2, right? 3x minus 1, that is. Okay, so remember, because x is 1 over 2, so that will be 1 over 2. So you can check out your r value. Your r value is 1 over 2. Right, if you substitute 1 over 2 there, you get 2 times 1 over 2, 3 times 1 over 2, which is 3 over 2 minus 1, and that will give us 1 over 2, right? So sum to infinity, so we are taking the sum all the way till infinity. Our a value is equal to, we said our a value is equal to 1, okay? And our r value is equal to 1 over 2. So the sum to infinity, okay, I'm just going to get some more space there. The sum to infinity is equal to a over 1 minus r, and this will give us 1 divided by 1 minus 1 over 2. Right, and if you look at this, right, 1 minus 1 over 2 gives us 1 over 2. 1 divided by 1 over 2 will give us 2. All right, so please remember this is the sigma notation, right? We get the a value first, okay, and get all the r value again, as well as, in this case, just work out the sum to infinity for that. All right, so let's get to the last question. They say the first 3 terms of a geometric sequence, right? So again, it is a geometric sequence, has a sum of 21. Okay, so let's write that down, right? Shall we? So that means, now remember, for a geometric sequence, right, we know that the general term is ARN minus 1. Right, so if I've got T1, right, my first term, that will be A to the R, that's N would be 1, so 1 minus 1 would be 0, right? And in this case, anything to the power 0 gives us 1, so that will be A, right? And in this case, your T1 will be A, your T2 will be AR, your T3 will be AR squared. So we keep multiplying by the common ratio, right? Now, they are saying to us the sum of the first 3 terms will be equal to 21. So if we write that down, that means that A plus AR plus AR squared will be equal to 21. Okay, we can take out A as the common factor there if we want to. Okay, so that will be 1 plus R squared. Okay, this will be equal to 21. Let's call that equation 1. Right, and then they say to us their product is 64. So which means if we take the product of all of these, this will be A multiplied by AR multiplied by AR squared. This will be equal to 64. Now if we multiply all of those together, A times A times A, that will be A cubed, right? And we've got R times R squared. The bases are the same. We add the exponents. So that's also going to be R cubed is equal to 64. So to simplify, we can take the cube root on each side. Okay. So we get AR. Okay, after taking the cube root of 64, that should give us 4, I believe, right? You can verify that. Shift, if we take the cube root of 64, that definitely gives us 4. Right, so that tells us that AR is equal to 4. Now I want you to note in this case, what do they want us to find? They say determine the value of the first term, right? So we want the value of A, right? And now let's see. If I want to find the value of A, what I'm simply going to do is let's make R the subject of the formula. So R, going to divide by A on either side, right? So I'm going to have R is equal to 4 over A, right? So that will be 4 over A. Now, if I substitute for R into my equation, right, into equation 1, so let's call this equation 2. So I'm going to substitute R into I'm going to substitute equation 2 into equation 1. So I've got A into, right, so I've got 1 plus, we've got R, which is 4 over A, plus R squared, which is 4 over A squared, right? And this will be equal to 21. Okay, so in fact, we shouldn't have taken out the common factor there yet. Okay, so that will give us 1. All right, so if we multiply the A back, that will give us A times 1 will give us A. Okay, let me write this properly. So that will be A. A times 4 over A, remember, the A will cancel out with that A at the denominator. So I'm left with 4. And here I've got 16 over A squared. Right, if I multiply that by A, that A will cancel out one of the A's. So I'll be left with 16 over A. And this will be equal to 21. Right, so what I'm going to do is multiply everything by A so that I get rid of the A in the denominator. Right, so that will give me A squared. Right, if I multiply by A on the left hand side. But remember, what I do on the left, I do on the right. So that will be A squared plus 4A plus 16, which is equal to 21A. And now let's try to solve. So we've got A squared plus, if I bring the 21 to the other side, it becomes negative 21. So negative 21 plus 4, that will give us 17, negative 17, that is, plus 16, and this will be equal to 0. Now we can factorize this out. So that will be A and A. That will be 16 and 1. Okay, and by the way, we get A is equals to 16 or A is equal to 1. Now remember, they had given us a restriction. They said R is an element of integers. So which of those A values would make R the element of integers? right? Which means that r should be a whole number, right? So r, in this case, if I take a is 16, my r value from equation 2 will be 4 over 16. And you can see this is 1 over 4. That's not an integer, right? But if my a value is 1, that will be 4 over 1. And definitely that is an integer, which is 4. So a is not equal to 16, but a is rather equal to 1. And essentially, ladies and gents, that is how the cookie crumbles, right? Apologies that I had to write it within this smaller space that we have, but I'm sure that you got the gist of it. All right, let's move on to the next question. And now we have a look at question 3. They say, consider the following quadratic number pattern. We've got 3, 12, and 33. So let's write it down. And we've got 33. Now, the first thing that we're going to do with any quadratic number pattern is that we need to find out what the first difference is, right? Our first difference is going to be 12 minus 3. That gives us 9. And we've got 33 minus 12. That gives us 21, right? And let's find out what is our second difference, right? If I say 21 minus 9, okay, so that will give me 12, okay? So remember that the second difference is actually constant. So that means I'm going to actually add 12 again to get the next term of my first difference, right? So that will be 21 plus 12, which will give me 33. And now to get my next term of the sequence of the pattern, I'll say 33 plus the 33, which will give me 66. So the next number should be 66. Right, now they say to you, determine the general term of the quadratic number pattern in the form an squared plus bn plus c. Right, so now let's look at this. So Tn is an squared plus bn plus c. Now remember, to get the value of a, we take the second difference, and we say the second difference is 2a. And we know that the first difference will be 3a plus b. And we know that the first term of the sequence is a plus b plus c. All right, let's find that quickly. So 2a will be equal to 12. So if we divide by both sides, by 2 on both sides, then our a value will be equal to 6. And then we know that 3 times a, but we already know what our a value is. So 3 times 6 plus b will give us the first term of our first difference. That will be 9. Okay, so that will be b is equal to, now 3 times 6 gives us 18. If we take it to the other side, 9 minus 18 gives us -9. So that's our b value. And finally, we've got c. Now we know a plus b plus c gives us the first term, right? Our a value is 6, right? Plus our b value, which is -9, plus our c value, which is what we want. This is equal to 3, the first term, right? So 6 minus 9 gives us a -3. But if I take it to the other side, it will be 3 plus 3. Then this will give us 6. All right, so now, which means that Tn will be equal to, our a value is 6, so that's 6n squared. Our b value is -9, so that's -9b, plus c, which is also 6. And that is how we are going to find our general term of this sequence. Right, now the next question. They say to us, which two terms in the quadratic pattern will have a difference of 345? So what this simply means, ladies and gents, is that we're going to take, right, whatever Tn will be, minus the term before, which is Tn minus 1, right? This will be equal to 345. Now, let's do this. In fact, we need just a little bit more space. Okay, let's just remove all of this that we have. We've already found our general term. So let's do this. If I say Tn, that's our original pattern, right? So that's 6n squared minus 9n plus 6, right? And this is subtract. Now remember, everything where I've got n, right, will actually now have n minus 1. So this will be subtract 6 into, where I've got n, I put n minus 1 squared minus 9 times n minus 1. This is plus 6, and this will give us 345. Now let's try and work this out mathematically. So this will give us 6n squared minus 9n plus 6, right? So I'm going to keep that negative there. Now if I multiply inside this bracket, remember this becomes n squared minus 2n plus 1, right? So that will be 6 into n squared minus 2n plus 1. That's minus 9n plus 9 plus 6. This is 345. All right, so this is 6n squared minus 9n plus 6. Okay, so we want to make sure that we multiply everything in there. That's 6n squared minus 12n, right, plus 6 minus 9n plus 9 plus 6, which is 345. Now let's work out what is inside that bracket. So we've got a 12 there. So we've got 6n squared minus 9n plus 6 minus 6n squared, right? So I'm just taking the square term, right? For the n, you've got minus 12n minus 9n, right? So in this case, this would give us, remember, we're multiplying by that negative that is outside, so it will change sign. So this will be plus 21n, okay, and we've got 6 and 6 there, which is 12 plus 9. That will also give us 21. So that will be plus 21. Okay. In fact, that becomes minus 21. So very crucial that you do that as slow as possible so that you can get to the right answer. Right, so that guy and that guy cancel out. So we've got 21n minus 9n. Okay, so that will give us minus 12n. So this will be 12n, right? So we're done with those. And we've got negative 21, right, plus 6 in this case. Now, if I take that to the other side, so please note, if I say 21 minus the 6, that would give us minus 15, right? So that would be negative 15, which is 345. But if I take the minus 15 to the other side, I've got 12n, which is equal to 360. Okay, right, and of course I'll divide both sides by 12, and so n would be 360. Divide by 12, and that should give us 30, right? So please note in this case, that means that which two terms, right? Remember they asked us which two terms. So that will be n is equal to 30, as well as, and the term before that, n minus 1, that will be n is equal to 29. So those are the two terms that will give you a difference of 345. And ladies and gents, that is how the cookie crumbles. Let's go to the next question. Right, we'll look at question 4 now. They say the diagram below shows the graph of f of x, which is 2 over x plus 2 plus 1. That's a hyperbola. And g of x, which is a into x plus 2 all squared minus 8. That's definitely a parabola. Right, now they say to us both graphs pass through the origin, which is O. The vertical asymptote of S passes through D, the turning point of G. The asymptotes of F intersect at T, which is, right, so there's T over there. Right, we'll talk about that point and say A is the other x-intercept of G. Right, so firstly, I think when I looked at this question, I realized that the examiner might have just made a mistake. Right, now if you look at your hyperbola, it has an a value that's positive. However, it looks like when they drew it, remember if the a value is positive, it would be on the first and the third quadrant of your imaginary plane, right? So in this case, this is in the second and the fourth. So it can only happen if our a value is negative. So ladies and gents, I think for the purpose of just making sure that we are true to the question, I'm going to make that a value negative, right? So they say to us, write down the coordinates of D, the turning point of G. Now remember that when the graph of the parabola, right, is written in this way, it means that that will be the x value of my turning point. That represents the y value of my turning point. But what you need to keep in mind is that that x value needs to change sign, right? So that means that my turning point will be at x is negative 2 and y is negative 8, right? The y value retains its sign. So D would have the coordinates negative 2 and negative 8. So I'm going to write that down there. And negative 8. Right, now they say to us, write down the equation of the asymptotes of f. So that is going to be our hyperbola. So please remember, in the equation of the hyperbola, this guy represents what we call the vertical asymptote. Again, the vertical asymptote changes sign. That would be at negative 2, so which means this value here is negative 2. And that means that the horizontal asymptote is at y is equal to 1. So that means in this case, the equations, now please you write them as they appear, right? So x is equal to negative 2 and y is equal to 1, right? So that is how we get those values. Right, they say to you, determine the value of a. So we want to find out what the value of a is, right? This is for the parabola. So that means that we're going to have to find one of the points, right? In this case, other than, the turning point, we already have that there. But remember they said to us the graph passes through the origin, right? Okay, so for the sake of it, I'm just going to make sure that I use a different color. So I'm going to substitute the point 0 and 0. So which means g of 0 is equal to 0. So that means a into 0 plus 2 all squared minus 8 is equal to 0. So that will be 4a, right? So remember 2 squared would be 4. 4 times a is equal to, I'll take the 8 to the other side and I'll divide both sides by 4. And so a would be equal to 2. Right, so in this case, it means that my a value is 2. And of course, I'm expecting a positive value because that is a smiling parabola. Right, so our a value is equal to 2. Right, now they say to us, find the length OA. Ladies and gents, we need to always make it a point that when we look at the length, right, firstly, the length needs to be a positive value. Right, so we're looking at OA. So essentially what they are saying to us is find the other x intercept, right? Already know that this will be 0 and 0, okay? Now, let's find out what the other x intercept is. So that means this is where g of x is equal to 0. So remember that a is 2, so 2 into x plus 2 squared minus 8 is equal to 0. So that's 2 into x plus 2 squared is equal to 8. And if I divide both sides by 2, I get x plus 2 squared is equal to 4. But remember, ladies and gents, we can take the square root on either side, but remember this becomes plus or minus. So that means x plus 2, right? Remember the square root will cancel the square, will be equal to plus or minus 2. So notice we'll have x plus 2 is equal to positive 2, or x plus 2 is equal to negative 2. So we end up here with x is equal to 0, and it makes sense. It's that point 0 and 0. And the other one is at x is equal to negative 4. Now, another way that you could have also gotten this is that, remember that we've got the y, the x-intercept, the x value rather of your axis of symmetry, which is always halfway from any 2 points that are in the same, that share the x value, right? Y value rather. So in this case, I could get that to be negative 4. Right, so what is the distance OA? So OA would be equal to, right, that's 0 minus negative 4. And so OA will be 4 units. And please remember, because we're looking for distance, we must always express it as a positive value, right? So in this case, remember that the y values would be the same. So what would make the difference between the two points would be just the x values, right? All right, but either way, y is 0 over there. So OA, we just found that to be 4 units. Right. Now they say to us, determine the range of f. So remember that f is our hyperbola, right? Now, what is the range? So the range is where the graph exists in terms of the y values. But think about it. This hyperbola comes all the way from negative infinity, right? But now remember, this is y is equal to 1. It cannot cross that line, that asymptote, right? But also, what does it do? It goes again all the way to infinity, right? So in this case, it simply means that it is from negative infinity to infinity. But so y is an element of real numbers, right? So from remember, when we say real numbers, we mean it is from negative infinity to infinity. However, y cannot be equal to 1. All right, so please keep that in mind. Okay, right. So that's the only place where the graph doesn't exist vertically. Right, so in this case, they say the equation of the axis of symmetry of f with the negative gradient. Now remember that the hyperbola has got axes of symmetry, right? And we've got 2 axes of symmetry. The first one is at y is equals to x plus k1. Okay, the other one is at y is equals to minus x plus k2. Now to get k1 and k2 respectively, you need to substitute. Remember, the axis of symmetry, that those axes of symmetry would pass through, in this case, the intersection of your asymptote. So that means this is the point where x is negative 2 and y is 1. But remember, they said with a negative gradient. So we're going to stick with this one, right? So y is 1. When y is 1, right, x is negative 2 plus k2. So in this case, we're going to say negative times a negative becomes a positive 2. When we take it to the other side, it becomes negative 2. So negative 2 plus 1 will give us negative 1. So K2 will be negative 1. So which means the equation of the axis of symmetry will be negative x minus 1. Okay, so that is that point there. So y will be minus x minus 1. Okay, right, now let's get to the next portion. Right, I know you guys love these questions. They say, for which values of x will g of x be less than 0? Right, now remember which one is g of x. G of x is our parabola, right? Where is the parabola less than 0? Where is it below our x-axis, right? It will be between x is negative 4. This is where our graph is less than 0. Between negative 4 and 0, right? So we can say x is an element of negative 4. Now remember, they just said less than 0. So that will be from negative 4 all the way to 0. And we are going to exclude both values, right? Another way of writing this answer is that x is less than 0. X is greater than negative 4. Right, now let's go to the next one, guys. So g of x multiplied by f of x is greater or equal to 0. Now remember, well, what does this mean when I say greater than or equal to 0? It means that we've got a positive, right? Where is the product of the y values of both graphs going to give me a positive? Now remember, when do we get a positive value? When we multiply two things, right? When both of them are positive, right? So where are both graphs, okay, positive? I can see on the left hand side, right, on the negative side, and you see that the graph of f is always above the x-axis, right? So it is going to be always positive, right, before negative 2. However, the graph of g is only positive, right, from negative infinity. Remember, it will come all the way from negative infinity until this point. Then it starts becoming negative from there. So it is going to be positive. Both graphs are positive between negative infinity, right? So if you notice there, both graphs are positive there, right? So between negative infinity and up until that value of x is equal to negative 4. So that's my first one, right? We'll arrange them properly afterwards. So from negative infinity till negative 4. But what's another place where the two graphs are both positive? Right, so I see that the other one starts becoming negative all the way here, right? But so is our other graph. It is negative. We'll come back to that just now. But where do the two graphs become positive again? You'll see that from 0 all the way to infinity, both graphs are positive yet again, right? So we've got another solution at 0 to infinity. Right, now let's find another solution. So again, remember that we can have a positive when we've got both a negative times a negative also gives us a positive, right? Now, where are the two graphs negative? Well, I can see in this case from negative 2, this graph becomes negative, right? Okay, the graph of g, or of f rather, becomes negative, and the graph of y, f of x, also is negative there. Okay, so we're going to exclude that value, right, which is negative 2. Why? Because the graph of f does not exist there, right? So from negative 2 all the way to 0 and even beyond, right? So instead of saying from 0 to infinity, I would rather much say this is from negative 2, which is excluded, okay? And by the way, actually I should have included negative 4, because you can see that graph will give us 0 over there. So that will be negative infinity to negative 4, which is included because they said greater or equal to, right? And then from negative 2, which is excluded, right? Because the other graph doesn't exist, is undefined there, which is the graph of f, and all the way to infinity. In this case, it will be excluded, included there, right? And that is our solution. So we can say x is an element of this guy over here, or you can simply say, if you want to put it in inequality form, that x must be less than negative 4, right? And actually, let's put it nicely. X is less than negative 4, but x must be greater than negative 2. Okay, right. So those are the values that we've got there. Right, so let's go to the next portion, or the last portion. They say determine the values of k for which h of x is minus g of x. So what are we doing? Right, so firstly, we are reflecting the graph of g, which is the parabola, right, around the around the x-axis, right? So which means everything that was negative now becomes positive. So when you say minus, this is essentially what you are doing to the graph. Okay, let me just redraw it nicely. Okay, let's just show that much better. Right, so we are reflecting the graph of g, right, around the x-axis. So which means your turning point will now be, now remember, your turning point, your x value of your turning point will still remain the same. It will be negative 2, but your y value now becomes 8, right? It becomes positive. Right, now we've reflected the graph, and we want to know, if we reflect the graph, how much do we need to shift the graph so that it will have two distinct positive, two distinct roots with the same sign. Now I want you to note, please guys, if I take the graph up, right, the green graph, if I shift it up, what will happen to it? It will now do the following. Okay, so if I shift it up, the turning point will be there, and I'll start having the graph do something like this, right? So your roots, the one would be positive and the other would be negative. So I don't want to shift the graph upwards, right? So the only way to go is if I shift the graph downwards, and look at what happens. If I shift the graph downwards, then my graph begins to look something like that, okay? So now they want us to have two roots with the same sign. Do you see that both of the roots there will have the same sign, right? If I shift it down, so which means my k value must actually be negative. I must shift the graph downwards, okay? But I must shift it down. I cannot shift it to the point where I've got only one root. That is, it touches the x-axis, right? Because then it would have only one root in that case. They said definitely two distinct roots with the same sign. So the value of k firstly must be negative, right? And I must shift it down by no more than negative 8. Now remember, it is 8 there, so which means I must take it 8 units down, right? So k must actually be a value which is -8, or rather it must be between 0, right? So I can leave it as is, or rather shift it down just a little bit, right? So it must be between 0, right, and -8. Okay, so k must be an element of -8 till 0. Now remember, in this case, it mustn't get to -8, nor must it be shifted, not be shifted by any amount. So it will be between -8 and 0 in that case. Ladies and gents, I hope that makes sense, right? We will leave that question there. Let's go on to the next one. And now we go into question 5. They say in the diagram below we've got f of x, which is 3 exponent x, right? And g of x, which is minus x plus 1, right? So they say to us, write down the coordinates of c. So this is an exponential graph, and we know for the exponential graph, when x is 0, your y will always be equal to 1, right? Because if you take f of 0, right, that will be 3 to the exponent 0, which is equal to 1. So c will have the coordinates 0 and 1. Okay, right, so that is what we get for the value, or rather for the coordinates of c. They say write down the range of f of x. Now note, in this case, our graph has got an asymptote at x is equal, or rather at y is equal to 0, right? It will never touch the the x-axis. So our graph would have y is an element of 0 to infinity. Or you can just simply say that y is greater than 0. Okay, right, remember it can only be greater than, it doesn't touch the line y is equal to 0. Right, now they say to you, determine the equation of the inverse of f in the form y is equal to. Now remember, guys, when we are changing the exponential graph, right, so we've got y is equal to 3 exponent x. Now I'm just showing you this. The inverse of the exponential graph becomes the log graph, and all you simply do is that it's going to be the log. This base becomes the base of your log, and that simply becomes the index of your log, right? But to see that without necessarily dragging it, so what you do for the inverse is that you always swap the x and the y. So x. And now on to question 5. So they say in the diagram below, the graph of f of x, which is 3 exponent x, and g of x, which is minus x plus 1, are given. Right, they say write down the coordinates of c. So remember, for the exponential graph, right, remember that it always will pass through where x is equal to 0, y will be equal to 1. So that means f of 0, right, that's 3 exponent 0, and 3 exponent 0 is 1. So the coordinates of c will be 0 and 1. Right, they say write down the range of f of x. Remember, this is where the graph exists in terms of the y values. So remember that it's restricted by the x-axis, right? In this case, that represents its asymptote, right? The line x is equal to, rather y is equal to 0. So that means that y must always be greater than 0, right? Or you can write it as, if you want to write it as elements, right? So y is an element of 0, right, all the way to infinity. Right, and now for the next one, they say determine the inverse of f in the form y is equal to. Now please remember, for the exponential graph, right, when you write it as a log graph, all you have is that y will be equal to the log of, now note the base there becomes the base of your log, and your exponent rather becomes the index. Okay, right, so y is equals to log base 3 of x. All right, now they say to you, for which values of x is f, the inverse graph, less than -1? Okay, right, so for your log graph, remember that what was going to happen to this graph is exactly the opposite of what happens in the graph of f of x. So let's say if this one is restricted by the positive x-axis, the inverse graph will be restricted by the positive y values, right? The positive y-axis, that is. Right, I'm trying to draw the graph. Right, so if this one has got the coordinates 1 and 0, 0 and 1, the other graph will have the coordinates 1 and 0. Right, so now I want you to note in this case, we are looking in fact for where the graph is less than -1, the log graph, okay? So let's do this. Where is it equal to -1, right? So if you look at it, there are two ways in which we can look at it, but I'm just going to choose one for the sake of time. So where is log base 3 of x equal to -1? Right, so remember, when you are solving for logarithms, right, so what you simply do is that your index, in this case, that will become your answer, your solution, right? Your base becomes the base of your exponent, and your answer in this case becomes your index, right? So they actually change. That's your exponent, right? So that's 3 to the minus 1. So they want to find out, in this case, the values of x. So 3 to the minus 1, this is actually 1 over 3, right? So where is the inverse less than -1? So it is -1. So when y is -1, x is actually 1 over 3. That's what we found out. So that means, where is it less than that? Where x is actually less than 1 over 3. But remember that x must be greater than 0, right? Okay, so this is for x greater than 0, but less than, we said 1 over 3. Okay, or you can say x is an element, right? So please remember, every time we write that, so we say x is an element of 0. Remember, it's non-existent at x is equal to 0. Okay, so that would be between 0 and 1 over 3. And that also would be excluded because they simply said less than that. Okay, right, and then let's go to the next portion. They say to us, okay, I'm just going to remove the graph of the inverse. So they say to us, if PQ is parallel to SR, okay, so let's look at that. So PQ parallel to SR, okay, and parallel to the y-axis. So these are perfectly vertical lines, right? So remember, if it is a vertical line, that means the x value at P will be equal to the x value at Q, right? And they say to us QR is parallel to the x-axis. So which means this line here is actually a perfectly vertical, horizontal line. So RS and QP are vertical lines, and QR is a vertical line. And remember, when a line is vertical, that means that the y values at Q will be equal to the y value at R, right? Okay, so let's look at what they want us to obtain there. They say determine the coordinates of S. Right. So we need to find out what the coordinates of S is, right? But remember, to get the coordinates of S, let's first establish there. We need to find out what are the Y values, right? We said they share the same X value with R, right? So we need to find the X value of that graph there. But remember, R value, right, is the Y value at R is equal to the Y value at Q, right? Now let's start at P. Right, where does the graph of minus x plus 1 cut through the x-axis, right? So we know that that would be minus x plus 1 is equal to 0. So x is equal to 1. So that means the value of P is 1 and 0. So that means this is the point Q would be where the exponential graph is equal to 1. So that is when x is equal to 1. Now to get the y value, we'll say 3 to the exponent 1, which is 3. So this is the point 1 and 3. But then it means that at R rather, we know what the y value is, right? So the y value at R is 3. Okay. Right. Now we need to find out. So we need to find out what would be the x value for this graph. When the y is 3, what would be the corresponding x value? So let's go back to the graph and say, well, g of x is equal to 3. So what would be the corresponding x value, right? So that means that minus x plus 1 is equal to 3. Minus x is equal to 3 minus 1 would give us 2. And so x is negative 2. So which means R has the coordinates negative 2 as well as y is 3. So now that we know that at S the x value is negative 2, we can get the coordinates of S. Can say, well, this is where f of x is negative 2. So f of negative 2 is equal to 3 to the exponent negative 2. And this will be 1 over 9. This is 1 over 3 squared, which is 1 over 9. So let's find the coordinates at S. So our x value would be negative 2 and our y value is 1 over 9. And so that's how we will obtain those values, right? And now they say to us, describe the translation of f of x to p of x if it is equal to 3 times 3 exponent x minus 2. So let's rewrite this. So this would be 3 times to the exponent 1 multiplied by 3 to the exponent x minus 2. So this would be 3 exponent x plus 1 minus 2. Now this is the graph of p of x. So remember, what have we done to the graph of f? The graph of f was just simply 3 to the exponent x. So we would have shifted the graph. Okay, so we shifted 1 unit. Now remember, this is a horizontal shift. Shifted 1 unit to the left. So remember, when that value is positive, it means we shifted to the left. And we shifted 2 units down. Okay, that's 2 units downwards. Okay, right, and that's how downwards, and that's how the cookie crumbles, ladies and gents, as we go on to the next portion. Right, and now we look at question 6. They say the purchase price rather of a machinery bought by a company 5 years ago was 80,000. Using the reducing balance method, calculate the annual rate of depreciation if the current book value of the machinery is 20,000. Right, now the first thing that we need to note, ladies and gents, is that we are using the reducing balance method. Right, now please, I want you to note, so we're going to say for the formula of the reducing balance method, that's A is equals to P. Remember, that's 1 minus I exponent n, right? So they say to us, when we bought it, it was 80,000. So that's the principal amount, right? But the book value now would be 20,000. Okay, so let's write that nicely. Okay, so that would be 1 minus. They want us to calculate, in this case, the annual rate of depreciation. So we are looking for the value of I. Right, and please, I want you to note in this case that this is to the exponent n. So for depreciation, because we are using an annual rate, in this case, that would mean that that would be 5, right? Okay, so let's do that quickly. So divide by 80,000 on both sides. That cancels with that. So you've got 2 over 8, which is 1 over 4. But what are we going to do? We're going to take the 5th root of that. Okay, let me just try to write it a little bit more neater. 1 minus I to the exponent 5. So we're going to take the 5th root of that. And of course, what we do on the left, we do on the right. So the 5th root of 1 over 4 . So the 5th root of 1 over 4. Okay, and I get a value of 0.76, right? So that means I plus 1 minus I rather would be equal to 0.757 right? Okay, but remember, I still need to transpose the 1. In this case, I will say that value minus the 1, right? So that answer, I'm going to subtract 1 from it. So what do I get? Right, so that would be I is equal to 0.24. Okay, so that is my annual interest rate. So if I need to get that in percentage form, remember that I just need to multiply by 100, right? So I'm just going to multiply by -1 there. Okay, I did something incorrect. Okay, so that's the value that I got. Okay, multiplied by -1. Okay, and that should turn that value positive, right? And just simply multiply by 100. Okay, right, and so that means that our annual interest rate, depreciation rate rather, should be 24.21%. Okay, right, and please remember, we're multiplying by 100 in this case, because remember that that would have been I over 100, okay, to get the actual interest rate. Okay, so the next question, they say calculate the effective interest rate per annum of an investment earning interest at 8.5% per annum compounded quarterly. Right, so we're going to say this is 1, right, remember how we calculate the effective interest rate. Always say 1 plus I effective, right, will be equal to That's 1 plus I nominal over n exponent n, right? So we are looking for the effective interest rate. So now let's substitute. Our nominal interest rate was 8.5%. Please remember that we're going to express it in this case as a decimal. So that's divided by 100. So that's 0.085 divided by, remember that they said to us it is compounded quarterly. So that means that our n value is equal to 4. Right, raised to the exponent 4 rather, and this is minus 1, taking that 1 to the other side. Right, let's quickly calculate this. Right, and I want you guys not to waste a lot of time when it comes to these. Right, you know what to do. Right, that's 0.085 over 4. Right, exponent 4. That's minus 1. All right, so our effective interest rate would be equal to, so we've got that value multiplied by 100, and that should give us 8.77%. All right, so this is our effective interest rate. All right, ladies and gents, let's go on to the next one. They say to us, a parent made an initial deposit of X rands, right, into a study investment account. So I think this one requires that we kind of draw a timeline, right? So here we are making an investment, right? So this is a T0, okay? And we are making an investment of X, right? And they say to us into an investment account, 3 years later, a further amount of 15,000 is deposited. Okay, so we know 3 years later, in this case, I don't know whether we will calculate this monthly, but we'll see. Right, we know that this is year 3, right? We make another deposit of 15,000, right? Okay, and they say to us 5 years later, 5 years after the initial deposit was made, 7,000 is withdrawn from the account. So now we are withdrawing at year 7. Right, we are withdrawing an amount of 7,000 rands. Okay, and they say the interest rate of for the first 5 years was 11% per annum, compounded monthly. So for the first 5 years, so let's look at year 5 here. Okay, so the interest rate would have been 11% per annum. So that's 11% per annum, compounded monthly, right? And then they tell us that thereafter the interest rate was 12% per annum, compounded half yearly. Okay, so from here we compound that amount, right? This is going to be 12%. Let me check. 12% per annum, compounded half yearly. Right, ladies and gents, let's now try to work out what would be the value of our investment, right? So this is what we are given. This is what our timeline would look like, right? So which means we are actually going to end up at year number 7. Let's see. They say calculate in terms of X how much money was in the account 3 years after the initial deposit was made. So now we want to find out how much did we have in 3 years' time. Right? So we want to find out how much money we have during this period. Right, so we're going to say, well, firstly, 6.3.1, the accumulated amount is equal to the principal amount, 1 plus I times interest, in this case, then the number of years. So this would be divided by M, right? N times M, right? Okay, so we're going to say the principal amount that we deposited was X. Right, we've got 1 plus, remember we're working at 11%, so that would be 11 divided by 100, which is 0.11, divided by, remember it is compounded monthly, so divide by 12. Okay, and how many months do we have in 3 years' time? So that would be 3 times the 12, and so that would give us 36. All right, so that's how we would find out how much money was deposited during that time. Okay, right, so that's the expression that we have. And then what happens thereafter? They say if the investment was worth 90,132 and 56 cents, right? After 8 years, calculate the initial amount that was deposited, that is the value of X. Right, so now we're looking for that value of X, right? All right, so I want us to quickly look, ladies and gents. So this would be year 8. They said after 8 years, right? Right, so that's 8 years. Right, so now what we need to find out, ladies and gents, is that, right, we've gotten the value that was deposited in terms of X, right? But what happens to this value, right? It will now further undergo another deposit, okay, right, of 15,000. So which means from year 3, we are going to add another 15,000 into the account, right? So we know that this will go through 2 stages. So 15,000 will go through the 11% per annum, but it will also go through the 12% per annum, but half yearly, right? So let's find for the other deposit. So 6.3.2. We've got the accumulated amount, which is P into 1 plus I to the exponent n, right? So that would be the 15,000 into 1 plus 0.11 over 12 exponent. So that would be 2 years, right? From the 3rd year to the 5th year, that would be 2 years. So that would be 2 multiplied by 12 times another, right? So this now becomes the accumulated amount, right, at year 5. But now it undergoes another interest rate, period, right, of 12%. So this is times 1 plus, now we've got 0.12, 12%, but this happens half yearly. So 2, this is to the exponent, this is 2 multiplied by, now the number of years, this is from year 5 all the way up until the end of year 8. So that's 3 years, right? So that's 2 times 3 years. All right, ladies and gents, so that is for the 15,000, right? So I'm going to leave it like that. And then now let's talk about then the amount that was withdrawn, right? It was withdrawn in year 7. So it's only for 1 year that it stayed inside our account, right? Or rather that it was withdrawn the year before. And this is when the interest rate was 12%. So I'm going to say, right, so this is the withdrawal. Okay. So the withdrawal would be 7,000 into 1 plus, again, 0.12 over 2. But in this case, even if it stayed for 1 year, but that is two semi or half years, right? So this is between the 7th year as well as the 8th year. So this is the withdrawal. But now I want us to also talk about this x value, right? So remember, we found out at year 3 how much we had, right? But we also need to find out, actually, we need to pull that to 5 years, right? So that our initial deposit, okay, so this would be the initial deposit, right? So this would be A into P, or rather A is equals to P, 1 plus I exponent n, but remember it will also have different interest rates that will apply to it. Right, so we've got x being dragged for 5 years first, under 11%, so let's write it out. So that would be 1 plus I again, exponent n. So that would be x 1 plus 0.11 over 5, this is divided by 12, the exponent of 12 times 5, right? But it also stays inside the account, so that's 1 plus 0.12 over 2, but now it stayed for another 3 years in this case, right? From year 5 to year 8, right? So it stayed for a further 3 years, 12% per annum. So 0.12 over 2, that would be 3 multiplied by 2. Now, ladies and gents, we need to add this amount to that amount of 15,000 that was added, right? And we are going to subtract the amount, the 7,000 that was withdrawn. And we know that all of this will give us that amount of 90,100 that will be given. Right, now I'm going to do that in my calculator, ladies and gents. So that would be, let's call this A1, okay? Let's call this, in fact, let's call this A2, right? So that you understand that. Let's call this A1 because that was the initial amount. So that means A1 plus A2 minus the withdrawal would be equal to 90,000. Okay, let me get that amount. 132 and 56. Right, so we'll get the calculation in just a little bit. Right, so now let's find out. So in terms of accumulated amount 1, I'm just going to keep it as A1, right? But the two amounts I'm going to add together, let's do that. So I'll say 15,000. That's into 1 plus 0.11 over 12, right? And we close that bracket. And this is yx2 times 12, which is 24. Right. So, and this is multiplied by another bracket. This is 1 plus 0.12 over 12, over 2. That's yx, right? That's raised to the exponent 2 times 3, which is 6. All right. So that's the amount that I get for the first accumulated amount of 15,000, right? And I'm going to subtract the withdrawal of 7,000 rands. So this is minus 7,000, right, into, that's 1 plus 0.12 over 2, right, raised to the exponent of 2. Right, so that's the amount that I will get. So that's 18,621 and, well, let's just say, 18,622, right? Okay, so this is the amount that I get, ladies and gents, right, from the A2 minus the withdrawn amount. Okay, so we are trying to get to x. So this was 18,000. Okay, that's 18,622. Right, now the accumulated amount 1 would be the difference between those two. So what I'm going to do with that amount, oops, I just did something there. Okay, all right, I can't recoup that amount, but nonetheless, you got the point. So I'm going to say 90,000. Okay, it's not ideal for me to round off at this stage, but because I did something to my calculator. Okay, so that's 18,622, right? So now I get an amount of 71,000, 71,510 and 56 cents. Right, so that's the amount that we've got. Now remember, our accumulated amount 1 is this whole thing, and this must be equal to 71,510 and 56 cents. Right, so which means I'm going to divide by this entire thing, all right, okay, on this side. So I'm going to take 71,000 and I'm going to divide by, this is going to be 1 plus, okay, so that would be, in fact, let's just remove it. So 71,510.56 cents. So divide by this entire thing would be, in fact, I think it would be easier if we did this, right? So that's divided by, that's 1 plus 0.11 over 12. Okay, and raised to the exponent at 12 times 5. Okay, multiplied by another bracket, that's 1 plus 0.12 over 2. And if we close that bracket, that becomes raised to the exponent 3 times 2. All right, ladies and gents, and I get my initial deposit. Of course, please just verify if you get the same amount. Okay, so we'll check if our answers actually correspond. So that's 158 and 23. And please remember, there might be just a slight discrepancy because I might have, just obviously because of the rounding off a little bit. Right, and so ladies and gents, that is really how the cookie crumbles on this question. Shoo, what a long question. But nonetheless, let's go to the next portion. And now we look into question 7, ladies and gents. Okay, let's go right into it. So they say determine f prime x from first principles. Right, so what we do is we're going to say, well, this is to get f prime x from first principles, we always say limit as h tends to 0, right, of f of x plus h minus f of x divided by h. Now remember, guys, we don't remove the limit as h tends to 0 for as long as h is in the denominator. Right, so let's take f of x plus h. So in this case, our f of x is half x squared, so this will be half of, everywhere I see x, I'm going to put x plus h, so that's 8x plus h squared minus half x squared, right? And please remember, if it is an entire expression, please remember to just put that in brackets, right? Because that will change the sign of every term in your expression. Right, so this is divided by h. Then for the next one, right, so this would be a half. Remember, inside your bracket, you've got x squared plus 2xh plus h squared minus a half x squared divided by h. Right, and if we multiply the half in there, limit as h tends to 0, we've got half x squared plus a half times 2 gives us 1, so that's xh plus h squared minus a half x squared, right, divided by h. Now notice this guy and that guy cancel each other out, and now we can take out h as a common factor, right, at the numerator. So we've got h into x plus h divided by h, right? So limit as h tends to 0, so that cancels with that. And now we can drop the limit because we're going to substitute h is equal to 0. So now this gives us, okay, so this will be x plus 0. And so that means that f prime x will be equal to x. All right, I hope that you got that, ladies and gents. Right, so f prime x is equal to x, and it does make sense. Right, so for the next portion, they say find the derivative of that entire expression. If you don't mind, I'm just going to remove everything here. Right, you can just rewind to see what I've done. Okay, so let's find out the rest. So remember, before you take the derivative, what you need to always make it a point of is that every single one of your variables, your x variables in this case, is actually in the numerator, right? So it is the case in that expression. So f of x is 1 over 5 x exponent 5 minus 6x. Now x is in the, rather your exponents are in the numerator in this case, or your variable is in the numerator rather. So that would be jumped down, 5 times 1 over 5, that will give me 1, right? That's minus 1. So that would be x to the exponent 4 minus, right, so negative 2 times negative 6 would give me positive 12 x. Now minus 2 minus 1, so that's x minus 3. Right, so this is f prime x rather. All right, so that's what I have as my final answer for that one. All right, and then for the next question, they say to us, okay, if you wanted to express it as a positive exponent there, that would be x to the power 4 plus 12 over x cubed. All right. Okay, so they say find d dx of that expression. Now what I'm going to do is, remember, we are squaring this entire thing, right? So remember what you've got there is x plus square root x into x plus square root x. Now please, ladies and gents, stay with me. You do not remove the d dx until you've simplified the expression that is inside the bracket. Now this is going to be x squared. Remember that's x times x. Now you've got x multiplied by root of x, right? So that's x times root of x is x to the power 1 over 2, right? Now remember, bases are the same, right? And what do? We add the exponents. So this would be x to the exponent 3 over 2, right? 3 over 2, because it would be 1 plus 1 over 2. But remember, we're going to repeat this twice. So I'm just skipping a step here. So this would be 2x to the 3 over 2 plus, now remember, root x times root x, this would simply give us x. And now we're ready to differentiate. Okay, and so this would give us 2x plus 3 over 2 times 2 would give us 3, right? That's minus 1. 3 over 2 minus 1 gives us 1 over 2. And this is plus 1. Right, and please note in this case, if you want to express it in with a third, right, this would be 2x plus 3 root of x plus 1. Right, really not necessary, but that is really how you would write it down. Right, ladies and gents, and that is really how this question ends. Let's go to the next question. All right, and we look at question 8 now. They say given f of x, which is minus x cubed plus 12x minus 16, show that x minus 2 is a factor of f of x. Now remember, for it to be a factor, ladies and gents, that means that when I substitute, now please note, I substitute the value rather with a changed sign, right, in this case. So f of 2, that will be minus, okay, minus 2 cubed plus 12 times 2 minus 16. And in this case, if it is a factor, it must give us 0. And so that's how we will show that f of 2 is actually 0. So that means x minus 2 is a factor. Now they say determine the x-intercepts of f. Right, now stay with me. We've now found out that x minus 2 is a factor. So we're going to use our remainder and factor theorem. So f of x, ladies and gents, please just stay with me on this one. Minus 12x minus 16. Right, so if we factorize this, that means that x minus 2, right, now we need to find the quotient, right? So x multiplied by what will give us minus x cubed? That will be minus x squared, right? So let's look at the last term. Negative 2 multiplied by what will give us negative 16? That will be positive 8, okay? Now, I always write this middle term as just bx, right? And all you simply do is, let's take our x squared terms, right? That will be the first term of my first bracket, the last term rather of my first bracket. So negative 2 times negative x squared, that will give me positive 2x squared. Okay, so please allow me to remove this. So that will be 2x squared. And what's another x squared term? That's x times bx. That will give us bx squared. Now note, this will give us the x squared term in our original equation, right? But what's our x squared term? So this is the same as minus x cubed plus 0x squared plus 12x minus 16. So, which means our x squared term is 0x squared. So let's drop down the x squareds. So that's 2 plus b. This will be equal to 0. And so b will be negative 2. So that means in this case, if I factorize that, okay, that simply becomes, that value there will be minus 2x. All right. So let's find the x-intercepts. So we've got x minus 2, and this is equal to 0, right? So we know that x is equal to 2, or that entire expression is equal to 0 minus x squared minus 2x plus 8 is equal to 0. So let's multiply everything by negative. So that's x squared plus 2x minus 8 is equal to 0. All right, and if we factorize it, we've got x. So we've got 4 and 2. And look at this, x minus 2 appears twice. That tells you that that must be your turning point as well, right? So what are our solutions, right? So we've got x is equal to negative 4, or x is equal to 2. Now, do you see that x is equal to 2 appears twice, right? So remember that if it appears twice, in this case, it means that it must be a turning point. All right, let's go to the next point. So they say determine the coordinates of your turning points. Right, I know that definitely the other one should be x is equal to 2, but let's find the other turning point. How do we do so? Right, we're going to take the derivative and make it equal to 0. That's minus 3x squared. That's plus 12 is equal to 0. Right, that's the turning point. And so minus 3x squared is equal to negative 12. If I divide by negative 3 on either side, so x squared is equal to 4. And so x is equal to plus or minus 2 if we take the square root on either side. Now, do you see that positive 2 does appear there? We did say that this will be our turning point as well. But remember, we are looking for the coordinates of the turning point. So I know that one of my coordinates will be at 2 and 0 because I've already found out that my x-intercept is 2 and 0. So the other one, all I need to do is substitute negative 2 into the original equation. So that's negative 2 cubed plus 12 times negative 2 minus 16. All right, sorry for squeezing that in there. So that would give us, that's negative 8, that's positive 8. Okay, minus 24, 12 times 2. Okay, that's minus 16. Right, and you can see that would be minus 40 plus 8, which would give us negative 32. Right, so we've got two turning point values. Right, the one is where x is negative 2 and y is negative 32. The other one, okay, is where x is 2 and our y value would be 0. Right, and as I suspected, they would say sketch this graph. Okay, let's try to sketch that graph. What would it look like? Now notice, ladies and gents, that the a value is negative. So remember that when the a value is negative, it will start as a decreasing function and then becomes an increasing function. But in this case, I know I've got two turning points. I always start there. My first turning point is -2 and -32, right? But if my graph starts as a decreasing function, so this means that this will be concave up, all right? And my y-intercept is at -16. And I know that my other turning point will be 2 and 0. Okay, so I know my graph is really not going to be the best, but you'll get the point nonetheless. Right. Now you remember our other x-intercept was at -4. Right, so please remember to label your x's as well. So that's your x and that's your y-axis, and this would be 2. So this is the point 2 and 0, and this is the point -2 and -32, and this is the point -16, right? And really that is your graph in essence, right? Okay, so that's what our graph looks like. So they say determine the equation of the tangent at the point of inflection. Now guys, this is very important for us to note. When we have to find the equation of the tangent, right? So first of all, where is our point of inflection? I can already see that my x value of the point of inflection will be 0. But how do we get that? It is the midpoint between my x values of my turning points, right? So I would say -2 plus 2 divided by 2, and that would give me 0. Otherwise, to get the x value of the point of inflection, you say the double derivative is equal to 0. So what is our double derivative in this case? The derivative of the derivative. So that would be -6x, okay, is equal to 0. And so if you divide by -6, you still get x is equal to 0. But now we need the coordinates of the point of inflection. When x is equal to 0, we know that y is equal to -16. That's the y-intercept, isn't it? So we know that this is going to be 0 and -16. Now let's find out what the derivative is at x is equal to 0, right? So the derivative in this case, we say that's -3x squared plus 12. So f prime at 0, that's -3 times 0 squared plus 12. Okay, so we get the derivative, or in this case, the gradient of the graph. That would be y is equal to 12x plus c. But how do we get the c value? We are now going to substitute the point of inflection, because that's the derivative, or rather that's the gradient or the tangent at the point of inflection. So we know when y is -16, right? In fact, our c value will be -16. Our x value is 0 plus c, so this will be -16. So our graph, the graph of the tangent, the equation rather of the tangent, will be y is equal to 12x minus 16. Right, so I hope that you got that. Okay, and please, if you don't understand this part, please watch the video on finding the equation of the tangent yet again. Right, and then finally, they say to us, they've given us a sketch graph there of p prime of x. So note, they are simply saying this is the gradient. Okay, this is a graph that represents the gradient of the graph of P. Notice it is always positive. The graph is positive, okay, and it only becomes 0, right, at that point there. Right, so they say for which values of x is the graph of P of x increasing? Right, now I want you to note in this case, when is a graph an increasing function? When P prime x is greater than 0, okay? So where is this graph that's given of P prime x greater than 0? Well, for x is an element of real numbers, it is always positive. It only becomes 0 at this point here, right? So in this case, we can say x is an element of real numbers. However, x cannot be equal to 0. Okay. Or you can say minus infinity to infinity, right? And x cannot be equal to 0, right? So they say for which values of x is the graph of P of x, px rather, concave up. Now, I want you guys to please note what happens when the graph is concave up. The double derivative, right? So meaning the gradient, right, of this graph, because this will be the gradient of P prime x should be greater than 0. Okay? Rather, the gradient of P prime x, so that means that the derivative of the derivative of x should be greater than 0. That's when we've got a structure that's concave up. So where is the derivative? Where is this graph, right, going uphill? I always look at it that way. Where is this graph going uphill, right? It's going uphill, right, as you go towards the right. It's from x is 0 all the way to infinity. So I will just simply say this is for x is greater than 0. Okay, right, and in this case that would be, it will be concave up at that point. Right, guys, I will leave it there for now. That's 8.2.2 done. Right, let's go to the next portion. Now, let's go on to question 9. They say in the diagram below, we've got ABCD, which is a square with a side length CD, right, 200 centimeters. PQRS is a rectangle with vertices on the sides of the square. And they say PB, BQ, SD, as well as DR is equal to X. So there it is. It's demonstrated there. Okay, so all of these are equal to x. Now, I want you to think about it, ladies and gents. The moment that they give you this, right, also just keep in mind, if this side here is x, right, equally that means that this side here should be, right, the whole side 200 minus x, right? I want you to see it that way, right? And then they say to us, show that the area of the rectangle is given by A, which is that entire expression there. Now, ladies and gents, let's quickly have a look at it. So, firstly, we need to get this side of the rectangle, right? It would be easy to get SR, right? And we need to get this side of the rectangle. And of course, in this case, we know that this should also be 200 minus x. All right, so now we're going to use Pythagoras, right? The Pythagorean theorem. So we know SR squared is equal to SD squared plus DR squared, right? So essentially we are taking this side SR and it's equal to the square of the other two sides. So this will be x squared plus x squared, and this will give us 2x squared. Right, so that's SR squared. Right, now if you want to, of course, you can just write it as SR, which would be the square root of 2 x, right? And then we want now the side RQ. So we're going to say RQ squared. This would be QC squared plus RC squared. And once again, you've got 2 times, in fact, let's rather say 200 minus x squared plus another 200 minus x squared. And so this is 2 times 200 minus x all squared, right? That's RQ squared. Now, of course, if you want to find RQ, that will be the square root of that entire thing, right? And again, what happens? You've got square root of 2 into, so 200 minus x, because the square root cancels out with the square. So that's the value of RQ. So now we are looking for the area of the rectangle. So that means that area would be the length times the breadth. So we can say that the length is RQ. Now let's just say SR, doesn't really matter, multiplied by RQ. All right, and in this case we've got root 2x multiplied by square root 2 into 200 minus x. All right, sorry, this is rather 200 minus x. In fact, I forgot to say squared for that, guys. So remember, we said that's 200 minus x, and 200 minus x, this was all squared, right? And we added those 2 there, okay? So this is 200 minus x. Right, so in this case, we've got square root 2 times square root 2. This will give us 2. And now we multiply the x inside the bracket, right? So this will be x times 200, that will be 200x. And x times x, this will give us minus x squared. And so that is the expression for the area over there. Right, and they say determine the value of x for which the area of the rectangle will be a maximum. Right, so we're looking for maximum area, right? So to maximize the area, we need to take the derivative, okay? They express that as a. I'm going to express it as a of x. So remember, to maximize or to minimize, you take the derivative and you make it equal to 0, right? So let me use that space there. A prime of x, right, will be equal to 0. So let's find those values of x. So if we multiplied a of x, let's start by doing that first, right? So a of x will be 400x, so that's 2 times 200x, minus 2x squared. And so a prime of x will give us 400 minus 4x. And this is equal to 0. The derivative must be equal to 0, right? So that means that 4x will be equal to 400. And if we divide both sides by 4, that means x should be 100 centimeters, right? So remember that our distance, or rather our perimeter, is expressed in terms of centimeters, right? Don't forget that part. Now, They say to us on the next one, what is the ratio of the maximum area of PQRS to ABCD? So PQRS is the rectangle. So let's find out what the area of that rectangle should be. So A of 100, the maximum area is when A is 100. So this is 9.3, right? That was 9.2. That would be 400 times 100 minus 2 times 100 squared. Okay, so that would be 40,000 minus 20,000. That should be 20,000 cubic centimeters, right? Rather square centimeters. That's the area. So this is the area of PQRS. But what's the area of ABCD? Remember, that was a square with all sides equal to 200. So this would be 200 times 200. So this will be 40,000 square centimeters. Right, and we're looking for the ratio of the maximum area of PQRS to ABCD. So PQRS to ABCD, that will be 20,000 to 40,000. But remember, when you express a ratio, it must be in terms of its most basic units. So I can divide both sides by 20,000. And so that will give me 1:2. And really that is the area, rather the ratio of the two areas. All right, and that is it, ladies and gents. Let's go on to the next question. Right. And now we go on to question 10. They say events A and B are independent events. Right? Now remember, ladies and gents, the moment that they tell us about independent events, what do we know? We know that the probability of A times the probability, the probability of A and B, okay, should be equal to the probability of A times the probability of B, right? So in this case, they say to us, if it is further given that the probability of A is 0.6 and the probability of B is 0.5, right? So that's what they give us there. They're asking, are the events mutually exclusive, right? Now remember, from mutual exclusivity, that means that the probability of A and B must be equal to 0, right? So if events are mutually exclusive, then it means that the probability of A and B must be equal to 0. But look at this. Because they told us that these are independent events, so if we take the probability of A and B, it will be the probability of A times the probability of B, and that will be 0.6 times 0.5, and that will give us 0.3. Ladies and gents, I want you to note 0.3 is not equal to 0. So are the events mutually exclusive? The answer to that is no, right? But why is that? Because the probability of A and B is not equal to 0. Okay. Right, and that is really how we are going to look at it. Now they say to us, represent the information on a Venn diagram. Right, ladies and gents, very important for us to know what we are doing here. Right? Now, because we already know that these are not mutually exclusive events, so that means that there is an intersection, right? In fact, just for me to get some more space, let me just get that circle. Yeah, there we go. Right, so in this case, this would represent element A, and this would represent B, and that is our entire sample space. Right, so where do we begin? They did say that these are independent events, and so they are not mutually exclusive. We've now found out that the probability of A and B, remember, probability of A and B, that would be that intersection there. And please, there's a video that I've made on probability, right, not too long ago. Please have a look at that video because it will really, really help you. It's really a summary of this section. Right, so in this case, I know that my probability of A and B, where they intersect, I know that this will be 0.3, okay? So that's where A and B intersect, right? And then, now what do I note again? They said to me probability of A is 0.6. So which means everything, remember when I say probability of A, that's everything under A. Okay, so that means in this case, this should be 0.6. Now that I've got 0.3 there, that means the probability of only A should be 0.3. So that 0.3 plus 0.3 gives me 0.6. And now they say for probability of B, remember, we had 0.5. So that means that's everything under B should be 0.5. Right, so if we already have 0.3, which means this guy here should be 0.2. Now, guys, I want you to please note. So if I add all of these, they do not give me 0, they don't give me 1. So which means my sample space is not complete. So 0.3 plus 0.3 gives me 0.6 plus another 0.2 gives me 0.8, right? So in this case, which means I still have, right, remember, that's 1 minus 0.8. I still have another 0.2 that's missing. And where is that going to fit? This is now outside in this case, which means that my sample space is not, or rather A and B are not exhaustive events, right? So in this case, it means that anything that's not A and B, in this case, would be 0. That's not rather A or B would be 0.2. Okay, right. Now they say to us, calculate the probability of only A. There we've got it. Only A would be something that does not include B. So only A would be equal to 0.3. And then they said the probability of not A or not B, right? So that's what we did right there. We found it to be 1 minus the entire thing there. You can say this is 1 minus all the things we added there, 0.3 plus 0.2 plus 0.3. Okay, and in this case, that would give us 0.2. And this is it right here. Okay, right, ladies and gents, that is really how the cookie crumbles there. Right, let's go to 10.2. These are contingency tables. They say the contingency table below represents 100 learners' responses regarding camping. Right, now they say to us, if a learner from this group is chosen randomly, what is the probability that it is a girl? So remember, what do? We take all the girls. So this represents all the girls, right? That's the total of all the girls out of 100 learners. So the probability of finding a girl would be 62 girls divided by 100 learners. And that would be 0.62. Okay. Right, and now they ask the question, is the event like camping independent of the gender? Now note in this case, what are we going to do? If events are said to be independent, we know that the probability of A and B should be equal to the probability of A times the probability of B. Now, I want you guys to please note. So this would be, if I say the probability, if I want to prove rather that the two events are independent, so let's say the probability of like camping, right? And so the probability of like camping and being a girl, right? Let's find that first. And what we're going to do is compare it with the probability of like camping and the probability of being a girl. You could have chosen boys, nothing wrong with that. Okay, so in this case, like camping, right? So where do we have girls that like camping? So this is girl and this is like camping. So 30 girls like camping. So the probability of like camping and girls, that would be 30 divided by 100. So that would give me 0.3. But now let's see. The probability of being a girl multiplied by the probability, in fact, let me write it in the correct order. The probability that we like camping multiplied by the probability of being a girl, right? So how many learners like camping, right? So you'll see that it's a total of 54. So that would be 54 over 100 multiplied by the probability of girls. We've already found that there. That would be 62 over 100. So that's 0.54 times 0.62. And if we multiply those two, we get a probability of 0.335. Okay? Or you can say 0.34 if you want to. The main point is that the probability of like camping and girls, right, and being a girl, is not equal to the probability of like camping multiplied by the probability of being a girl. So therefore, what can we conclude? The events are not independent. Okay? And the reason for that is that the probability of like camping and girl is not equal to the probability of like camping times the probability of being a girl, right? So remember, that's how you are always going to look at independent events, right? Okay, and essentially that is how the cookie crumbles when it comes to that. Right, and finally we've got one last question. Now, they say to us, there are only red balls and green balls in a bag, right? So we've got red balls and green balls. They say a ball is taken at random from the bag. The probability that the ball is green rather, is 3 over 7. So in this case, remember that every time, so we've got red and green, right? So I'm going to say red and green. So I know that the probability of taking a green ball would be the number of green balls divided by red plus green. Okay, and they tell me that this is 3 over 7, right? Okay, so if you want to, we can try to express this somehow. Okay, now if you think about it, that would simply mean that if we were to take this as a probability, then it means that the number of green balls would be 3, right? And so the total number of balls would be 3. We know green is 3, and so red would be 4, right? Okay, but let's look at the question further. They say the ball is replaced, right? The ball is replaced in the bag, okay? So which means we put the balls back. 2 more red balls and 3 more green balls are put in the bag, right? And thereafter the ball is taken at random, right, from the bag. The probability of getting a green, so this is now taking again. So the probability of taking a green in the second one. Now I want you to note, what have we done? We have now increased the number of red balls, okay? And we've increased the number of green by 3. So which means 3 plus the number of green balls divided by the total number of red would be 2 plus the number of red balls, 2 plus the initial number of red balls, and this would give us a probability of 6 over 13. Right, now they say to us, determine how many of each color was originally in the bag. Right, so let's try and express this first one as an equation. So I'm going to cross multiply there and say this is going to be 7g is equal to 3 into r plus g. Okay, so 7g is equal to 3r plus 3g. Right, if I take this to the other side, that would be 7g minus 3g. That would be 4g equals to 3r. Let's write it properly, 3r. And so we can express the green ball ratio as well. This is going to be 4 over 3, right, multiplied by r. Actually, green we divide by 4. Okay, let me just make sure that I get that correctly. So g would be equal to 3 over 4 multiplied by the value of r. Now, ladies and gents, this is now this is for the first one, right? From the first equation. Right, let me call that equation 1. Now from the second equation, let's cross multiply that. So what do we have? We've got 3 plus g, okay, and divided by 2 plus r, and that would give us 6 over 13. So that means that 3 plus g multiplied by 13 is equal to 6 times 2 plus r. Okay, now 13 times 3 would give me 39 plus 13g, which would be equal to 6 times 2 would be 12, plus in this case 6 times r, which would be 6r. Right, and again, if we have to look at it, okay, we can have an expression there and say, well, that gives us 13g plus, in fact, let me say 13g, 39 minus 12 would give us, all right, my head is blocked now. 39 minus 12 would give us 27. So 13g minus 27 would give us 6r. Okay, now we can call this equation 2 if you want to, and let's substitute r for let's substitute equation 1 into equation 2, right? And let's put substitute equation 1 into 2, and so what do we get? I get, so wherever I see g, I'm going to put 3 over 4r. So that means 13 times, right? So we've got 13g, right? So 13 times 3 over 4r minus 27 would give me 6r. All right, and we can just work it out. 13 times 3 over 4 would be 39 over 4r, right? If I take that to the other side, minus 6r, and this would be equal to 27. Right, let's work with fractions, ladies and gents. So if I say 39 over 4, right, and I subtract 6, that would give me 15 over 4, right? So that's 15 over 4r. Okay, so that's 15 over 4r would be equal to 27. Right? And to get the number of red balls, I'll just simply say 4 over 15 multiplied by 4 over 15. What I do on the left, I do on the right. And so I'd say, what is 27? All right, so that doesn't give us a whole number there. So that means, I don't know if I've done something incorrectly there. So that means that the number of red balls, or maybe we can find the green balls first. Let me see if I did that correctly. So that's 13 over 4. Okay, that's 27. Okay, right, so I get 7.2, the number of red balls. And that means that the number of green, if I say 3 over 4 times 7.2, so we'd have to get a whole number here, right? You can't have 0.2 of a ball. So what I would do is actually multiply that, the nearest whole number. In this case, I can just simply multiply that by 5. 7.2 times 5 would give me 36. Okay, that's the number of red balls, right? And now, let's see, 36. So for green balls, you've got 3 over 4 multiplied by the number of red balls, that's 36. I get 27. Right, so I get the number of green balls to be equal to 27. And please verify this, ladies and gents. That is how I would go about this question, right? And essentially that is how the cookie crumbles. All right. Please, if you've got any more questions on anything that we've done, you're more than welcome to ask. But otherwise, ladies and gents, it's really been a pleasure being with you, right? And of course, if you need assistance, you are more than welcome to get in touch with us. And this coming weekend at the center as well as online, we'll be actually looking at paper 2. Please do join us there. Otherwise, I'll see you guys next time. Sharp, sharp.